All right, so we are going to be learning about the Pythagorean theorem. Just to give you a little bit of background information, there was a guy, his name was Pythagoras, I believe. And what he and his friends used to do is they used to get together and they used to just do math. And they would actually just get together and do math, which to me sounds like a really fun time. And some of the things that they worked with are shapes, and so they would work with triangles and look at relationships between side lengths and all of these things. So really what we're learning today is his work. There is a little bit of controversy if you're into like math drama, because some people say he actually wasn't the person who developed this theorem. It was actually the work of one of his friends. But anyways, you can research about that and you can see what you find. In order to learn about the Pythagorean theorem, first we need to just brush up some of our old skills. We're going to start with talking about the area of a square. So here I have a square. We're going to assume all the side lengths are the same. I have to warn you guys, when we're doing these questions, the diagrams are not to scale. So sometimes you might see like a 13-centimeter line and a 5-centimeter line, and they might not look very, very different. Just know they might not be to scale. So this is a square. That means every single side length is 5 centimeters. Does anyone remember the formula for area? Since someone had Tezzy? Yeah, good. So area is equal to length times width. I always want you to start every single question with the formula written down. We're going to sub in our values, which is going to be 5 times 5. And then we're going to solve. 5 times 5 is just going to give me the number 25. What kind of units do you have for area? Yep. Yeah, it's going to be centimeters squared. Okay, how about a question like number 2? This time, it's asking you for the length of the side of a square, and they've given us the area. This one is a little bit interesting. How do you go from area to side length? Does he? Yeah, often when I ask this question, if you have the area, students sometimes say just divide it by 4, but that's actually not going to give you the side lengths. If you had the perimeter, you could do something like that, but not with the area. The only way to go from area to side length is to take the square root of it. So let's try that with this. If the area is 169, our side length is going to be the square root of 169. And this is one of the numbers in your chart. What is the square root of 169? 13, and our units would just be centimeters. Okay, I am going to be showing you 2 different ways to solve a question involving Pythagorean theorem. The 2 different ways, and I'll outline them here. This is the formula method. So we will be reviewing the formula that I know you guys have seen before. And the other way is the square method. And the square method is not often taught a lot. How many of you have learned the square method of the Pythagorean theorem? Yeah, I would assume not a lot. So let's actually begin with the formula, because that's something you're very comfortable with. Whenever you have a right angle triangle, so let's draw that so we can label it. Okay, let's say I had a right angle triangle like this. How do I know it's a right angle triangle? Well, you're usually going to see a little box, and that box represents a 90 degree. And 90 degrees means it is a right angle triangle. When you are labeling your right angle triangle, you're going to call the 2 smaller side lengths A and B. And it doesn't matter where you put the A and the B. You can put them AB or BA. What is important is that you label the longest side. Does anyone know what that long side is called? Yeah. Yeah, you label the hypotenuse, which is always the longest length in a right angle triangle. You're going to label that C. And then you're going to use the formula above. A squared plus B squared is equal to C squared. So let's say I am asking you to tell me what the hypotenuse is. Well, the way that you would write that formula is you would just say C squared is equal to A squared plus B squared. Let's say I was asking you to tell me what the side length A is. Well, in that case, you would have to just move things around a little bit. And I know we haven't really talked about equations, which is why I'm just going to tell you what the formula is. So a squared would actually be equal to c squared minus b squared. And if I was asking you to find the side length b, well, we would write it as b squared is equal to c squared minus a squared. I know we discussed that C is the hypotenuse, which is the longest side. How do you know where the smaller side lengths are? Well, what I do is I just look at the right angle side, and then whatever two side lengths are attached to it, those are my smaller side lengths, and we're going to label it A or B or B or A. It doesn't matter. Okay, so we're going to practice using the formula, but before that, I also want to show you the square method, which I think is actually pretty cool. So take a look at this diagram. We have a right angle triangle. I'm going to draw in the little right angle sign just so that we know that that is our 90-degree angle, and A and B are our smaller side lengths. Now, this is actually how this formula was discovered or developed. What they did is they looked at the right angle sign and they drew squares around all of the different side lengths. So you have a square here, and I guess we can just color code it. So maybe I will color this in with pink. So we have a square here, and we have a square here. And those are considered to be our small squares. And the rule is, if you take the area of two of the small squares and add them up, it's actually going to give you the area of this larger square over here. Okay, I'll repeat that again. If you take the area of two of the smaller squares, so the ones that I've highlighted in pink, and you add them up, it's going to give you the area of the larger square, which I've highlighted in green. It might seem confusing, but let's go ahead and try a couple of questions to show us how this works. Okay, question number 3 says, find the area of the unknown side by using the square method. So if we were to analyze this, we have a right angle triangle. We have squares attached to all of them. Even though I know this one looks like a rectangle, just assume it's a square. We've been told that this area is 144 centimeters squared, and this area is 25 centimeters squared. Are these small squares or the large square? Good. So if we were to highlight them, we would put pink or whatever color you want to use. I'm just going to go ahead and use what I used above. So I'm going to use pink to describe the two small squares. And the rule is, like I said before, if you add up the areas of those small squares, it should give you the area of the large square. So what would be the area of this green square? Yeah, so all you would do to find the area of this is you would add together 144 plus 25. And that would give you 169 centimeters squared. Now, the question is not asking for this, but if we know the area of that square, can we also find the side length of it? Yeah, what would be the side length of the green square? Good. The length of this would just be 13 centimeters. Just for practice, what would be the side length of this small square? Good, 12. And what would be the side length of this? Good. So using the square method, you can actually find the areas of everything and the side lengths of everything. Okay, let's try this next example. So in this example, we have been given information that is a little bit different. First, I'm going to just highlight my two smaller squares. So this one over here and this one over here. And then my larger square is going to be this one over here. Okay, so I know the areas of the two yellow squares have to add up to give me the area of the two larger squares, but we don't have enough information. We know that this is 16 centimeters squared, that's the area, and we know this side length is 5 centimeters. Can we figure out the area of the orange box? Yeah, what would it be? Good, so we're gonna show all of our work. We're gonna go area is equal to length times width, which is equal to 5 times 5, which is equal to 25 centimeters squared. Okay, now I know the area of this box and the area of this box. How do I find the area of this yellow box over here? Am I going to add the areas together or am I going to subtract them? Yeah, and how did you know to subtract?
Because like above that the like if you mark like the box at 25 centimeters square, you can count that as b, and then you can count 60 centimeters square as a, and it says that b squared equals c squared minus a squared, so you can subtract that.
Perfect, exactly. We had said that the area of the two smaller boxes have to add up to give you the big box. If you know what the big box is and one of the smaller boxes, you just need to subtract them, and that way you can figure out the area of the smaller box. So the area here is just going to be 25 minus 16, which is 9 centimeters squared. And I know the question doesn't ask for it, but let's just figure out the side lengths of everything. What would be the side length of this square here if the area is 9? This would be 3 centimeters. Good. What would be the side? Oh, we already know the side length is 5. What would be the side length of this box here? 4 centimeters. Good. Okay, last but not least, let's look at question number 4. In this question, we are going to find the area of the unknown side by using the formula. And just to make this question easier for us, let's change it from decimals. Let's change this to 4 centimeters, and let's change this to 5 centimeters, and we're trying to find the question mark. The first thing I want to do before I start solving this question is let's label some of the sides. So I know the hypotenuse is going to be C for sure. Does it matter what we call the other two side lengths? No. So I'm just going to go ahead and call this one A and this one B. Based on what we said above, if we're trying to find B squared, we're going to be using this formula over here, C squared minus A. Okay, so I'm going to go back here and I'm going to write B squared is equal to C squared minus A squared. And now you're really just going to plug in the information. So B squared is equal to, what is C? Yep, or I'm just going to show all my work. So 5 squared minus A is 4 squared. 5 squared is 25. 4 squared is 16. What's 25 minus 16? 9. And then when we take this, to solve this, we just need to take the square root of both sides. So really, you're just going to be taking the square root here and here. If you have a square and a square root, that just becomes the number that's under the sign. And what is the square root of 9? It would just be 3 centimeters, and that would be our final answer. Question? Before you can start. So if you take a look at handout F, which is what you're going to be doing, I've kind of taken away all the decimal questions in this. I think, we've done decimals already. It's not a big part of the curriculum. So you can go ahead and cross out A, B, C, and especially E and F. So, and then for question 2, you can cross out C and E. And then for question 5, you can cross out F, G, and I. So anywhere where you see a decimal, you don't have to do those questions. If you wanted like an extra challenge, you definitely could. By the way, some of these are asking you to use the box method, so the square method. So question number 5 is asking you to use the square method. If it's not asking you, you could use the formula. It's completely up to you. Bye, recording.